All right, so we're looking at some more graphs involving sine and cosine. All right, so if we start with cosine, so just a reminder, our cosine graph is shaped like this. Um, 2 pi, 3 pi over 2, pi over 2, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Going from 1 to negative 1. All right, so our cosine it's got this shape. All right, whereas our sine has this shape. All right, so now we're gonna do some things like shifting it left or right. So a shift to the left or right of a wave-shaped graph, okay, this is a wave-shaped graph, is called a phase shift, okay? Two special examples of this are if I shift sine of x to the left, pi over 2, I'm going to get cosine. Okay, and we can see this. So if I take my sine graph, and I take every point, and I'm going to shift it to the left, pi over 2, which on my graph just means over 1 unit. Then what's going to happen is I'm going to get the cosine graph. Okay, so I took every point and I shifted it to the left by pi over 2. And what that does is that gives me the cosine graph. I can take the cosine graph and shift it to the right by pi over 2. And it's going to give me the sine graph. Okay, if I copy this down here. Okay, so I got my cosine graph. And I'm going to take everything to the right pi over 2. And you'll see the sine graph up here. Okay. Those are two specialty cases. You can shift either of these by whatever amount you want, and it's still a phase shift. Those are just some cool examples. All right, so the amplitude of a sinusoidal graph. So all of these wave-shaped graphs are just called sinusoidal graphs. So the amplitude is going to be equal to 1/2 the distance from the top to the bottom of the waves, or it's just the distance from the x-axis to either the top or the bottom of the waves. Okay, so if we do an example, let's say I want to graph 1/2 cosine. Okay, so I'll take, and I'm just going to graph it from 0 to 2 pi. That way I can make it bigger and it's a little easier to see. Anytime you're graphing one of these trig functions, it's generally standard to graph it from 0 to 2 pi, unless you're told otherwise. Okay, so my normal cosine graph look like that. All right, so I'm gonna graph, so blue is cosine of x. I'm gonna graph in red a half cosine of x. So multiplying something by a half out front means I'm gonna do a vertical compression. So everything gets bumped and down to a half and negative a half. Okay, so I can sketch that out. Okay, and so our amplitude, for the negative, or amplitude for just the regular cosine is 1. Okay, and you can either look at that as from the top of a wave to the x-axis, or it's half times top of wave to the bottom of the wave. And so from top of the wave to the bottom of the wave would be 2, and then divided by, or times a half would give you 1. For my 1/2 times cosine, I'm going to go from the top of my wave to my x-axis, and that's going to give me a half. That's my amplitude. All right, I could get that still if I did 1/2 minus negative a half, that would give me 2. I would then multiply that by a half, giving me a half. Okay, so those are, you can use either way for amplitude. They're going to give you the same thing, just whichever way is easier for you. All right, so then we've got what's called the period. So the period of an oscillating function. So an oscillating function is just one that repeats over some set amount. All right, so our period is just the length of a cycle. So how long before it repeats. All right, for functions that have a period of 2 pi, so sine, cosine, secant, cosecant, the period is going to be given by omega, which is equal to 2 pi divided by a. So generally, just a standard sine, cosine, secant, cosecant, your period is 2 pi, because it takes from 0 to 2 pi for that to repeat. If you start multiplying these by something else on the inside, so if we've got sine of 2x, our period is going to be given by omega, which is 2 pi divided by a. Our a in this case is 2, so 2 pi divided by 2, so pi. Okay, we can see this if we were to graph this. Again, I'm just going to go from 0 to 2 pi. All right, and so I'll do the basic sine graph so y'all can compare them. So the sine graph goes from 0 to 2 pi. Our sine of 2x, so that 2x, 2 on the inside of the function, means a horizontal compression by a half. Remember, horizontal changes, we do the opposite of what we think. So a horizontal compression means all of my x values are going to get compressed and tightened. So my graph will look like this, and we can see our period from 0 to 2 pi, because from 0 to pi. So pi being our period. Because after pi, it would then repeat one more time. Okay. Whereas our regular sine graph, it took it from 0 all the way to 2 pi to repeat once. Okay. All right, so those work for our periods with 2 pi. Now, we've got tangent and cotangent that only have a period of pi in their original function. So if that's the case, we divide A by the function's original period. So in that case, we use pi over A. Sorry. All right, and so then we've got frequency, which is given by lambda, and that's just 1 over omega, or whatever our frequency or our period was. Okay, so frequency is just 1 over our period. All right, so there are our graphs using sine and cosine and their frequency and period and phase shifts. If you've got questions on this, you can let me know in class or send me an email.